So very good morning. So today I am going to explain about the next topic is law of conservation of mass. Law of conservation of mass, or another term is there, continuity equation. So this is also called continuity equation. Okay. So what is the law of conservation of mass? Let's see. Very important topic regarding as a fluid mechanics in the as a mechanical engineering student. Okay. So what is the use of law of conservation of mass? When the quantity of liquid is flowing in a pipeline. So let us say this is the fluid. So this is the fluid and this is the pipeline. If you see clearly the diagram, here the diameter of the pipe is very low and here the diameter of the pipe is somewhat more than the entrance. Let's see, this is the section 1-1 and this is the section 2-2. That means what? Here the input and this is the output. So that means what? Here the pipe diameter is very low and here the pipe diameter is high. If the diameter increases or decreases, but the quantity of fluid will not change. So that is law of conservation of mass. So that means what? Suppose the diameter is very low and the diameter is high. Suppose the liquid is very quantity of liquid is very low here and the quantity of liquid is very high. That is not true in the law of conservation of mass. What about law of conservation of mass? It explains about that. When the quantity of fluid is same at any section, either it is low diameter or either it is a high diameter. Let's see the definition. A fluid flowing through the pipe, at all cross section, the quantity of fluid per second is constant. The quantity of fluid. So quantity is nothing but in terms of mass, in terms of kgs. So the quantity of fluid is per second is constant. That is about law of conservation of mass. Very important. So once again I am going to repeat. When the fluid is flowing through the pipe at all cross section, the quantity of fluid per second is constant, or simply the quantity of fluid per unit time is constant. Okay, that means what? Let's see. Let average velocity at cross section 1-1, and here you can get the velocity v1. Area of the cross section at section. So this area, so that is called A1, and ρ1 is the density of fluid at section 1-1. Here the ρ1. Same for the corresponding section, and here is the velocity v2, ρ2 density, and A2 area of the fluid. According to continuity equation, what you are going to explain simply, input is equal to output. That is what? That means what? The quantity of fluid per is constant. The quantity of fluid is constant. That means what? How much you are giving input is equal to the output. So according to law of conservation of mass, the rate of section at 1-1 is equal to rate of section 1-1-2. That means what? Mass flow rate. Mass flow rate at section 1-1 is equal to the mass flow rate at section 2-2. That means what? What is the input here? V1, ρ1, A1. So that means ρ1, A1, V1. And what is the output here? ρ2, A2, V2. Same output. So ρ1, A1 is equal to ρ2, A2, V2. Okay. And according to these equation, how do you know the quantity of fluid per second is constant? How do you know? Let's see. ρ1, A1, V1. So what is the density equations? Density units kg per meter. Area meter square. Velocity meter per second. So meter square into meter cube, and these meter cube will cancel, and you can get the units is kg per second. So what is kg per second? Mass by time. Quantity by time. So quantity per second is constant. So that means what? ρ1 A1 is equal to ρ2 A2 V2. So that is the explanation of law of conservation. Very important. And coming to equation, this one is equation ρ1 A1 is equal to ρ2 A2 V2. That is the input is equal to output. That is law of conservation of mass. Suppose and the same fluid is flowing from here to here. So because density is same, there is no change of density. So because ρ1 is equal to ρ2. For the incompressible fluid, what is it? I already told in the previous class, types of fluids. And the types of fluids in the incompressible fluid. Incompressible fluid was nothing but no change of density. So density is constant. So if you cancel the density in both sides, you can get A1 V1 is equal to A2 V2. Then rate of discharge Q is equal to A1 V1. So what is the A1? A1 is equal to area meter square and V1 is equal to meter per second. And meter square into meter cube per second. So this is the meter cube per second and this is the kg per second. This is volumetric flow rate and this is mass flow rate. Volumetric flow rate, mass flow rate. With regarding both, at the numerator is time. So meter cube per second, kg per second. So see clearly the difference between meter cube per second and kg per second. This is the quantity and this is the liquid and this is the for mass fluid and this is for mass and this is for liquid. Okay, this is about law of conservation of mass. Thank you.